Hello, in this video I'm going to be going over periodic trends and focusing on atomic radius. First of all, it's important to know that francium is the atom that has the largest atomic radius. So basically, as you go left on the periodic table, right to left, the radius gets bigger and bigger and bigger. And then as you go down the periodic table, down each column, the radius also gets bigger and bigger. So if you're looking at cesium versus francium, francium is bigger. If you're looking at radium versus francium, francium is bigger. If you're looking at barium versus francium, francium is bigger. But why don't we do some examples that may not be as obvious, some tricksters. Alright, in this worksheet, what we got is, it says for each answer, you should use orbit diagrams to show your reasoning. It's just the little thing like that, orbit diagram. So please list the following in order of increasing atomic radius. Alright, so we have lithium, rubidium, and potassium. And we have three rules. First rule is electron shielding is the most important concept. Always look at the number of shields first. Basically what that's saying is the number of shields is which row on the periodic table is it. The lower it is, the more electrons there are going to be between those outer electrons and the nucleus. So let's look at lithium. Lithium, let's cross that out. Sorry, let me put this back up. Lithium's right here. It has 1, 2 energy levels. So lithium 1, 2. And why don't we just redraw it? Sorry for scribbling. 1, 2. And then rubidium, we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And potassium has 1, 2, 3, 4. So electron shielding is the most important concept. Always look at the number of shields first. So the more shields it has, the larger this molecule is going to be. Alright. And please list the following order of increasing atomic radius. So we're looking for the smallest one. So it looks like lithium has the least amount of shields, therefore lithium is the smallest. And then we have potassium has 1, 2, 3, 4, and rubidium has 1, 2, 3, 4, 5. So it looks like potassium would be the next one. So I'm going to write down potassium, and then rubidium has the most shields, so that is the largest one. Another way of looking at it, maybe a little simpler, is looking at the periodic table. You have hydrogen, lithium, sodium, potassium, rubidium. Lithium's the smallest, potassium a little bigger, rubidium even bigger because it's getting closer to francium because it's getting more and more shields or layers of electrons being put on it, kind of like layers of an onion being added. Alright, moving on to the next one, we got barium, calcium, iron, bromine, and radon. So looking at barium, and I'm going to draw these shields, put it right over here. Barium is down here, so it's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. We've got calcium, which has 1, 2, 3, 4 layers or shields. Iron, we're going with this one, 1, 2, 3, 4. Same as calcium. And then bromine. It's down here, 1, 2, 3, 4 again. And then radon has 1, 2, 3, 4, 5, 6. Alright, so we have 2 that have a large amount of shields, 6, and we have 3 that have 4 shields, or layers, or energy levels. So, I'm going to scoot this out of the way. We got to go to the second rule. It says, if number of shields are equal, look at the number of protons. So the number of shields are equal for these three. we have to look at the number of protons. Given equal shielding, more protons means the nucleus is pulling in electrons more, making them smaller and harder to pull away. So that stronger nuclear force, the more protons, that stronger the nucleus, is going to pull those electrons towards itself, kind of imploding or making smaller that size of the atomic radius of that atom. Alright, looking at a periodic table now. What we have right here is calcium, iron, and bromine. Calcium, iron, and bromine. So which one has more protons? Bromine does, 35 as opposed to 26 or 20. So bromine is actually going to be the smaller one. It has the same number of shields as calcium iron, however it has more protons, therefore a stronger ability to draw those electrons towards itself. And then iron would come next, and calcium would come after that. And if you look at it, bromine, iron, calcium, the one that's closest to francium is calcium, so it should be the biggest one of those three. Next, we have barium and radon. Barium's over here, radon over there. Radon has more protons, so it is going to be the next largest, but then the very largest is going to be barium, again because it's closest to francium, and it does not have as many protons as radon does, so it doesn't have as strong of that nucleus attraction, getting those electrons closer to itself. And that is the order: bromine, iron, calcium, radon, and barium for smallest to greatest atomic radius. Alright, let's do the next one, and that's calcium, chlorine, calcium 2 plus argon. Calcium, let's look at this guy right here. 1, 2, 3, 4. 1, 2, 3, 4. Chlorine, 1, 2, 3 of them. 1, 2, 3. Calcium 2 plus. 1, 2, 3, 4. However, it lost 1, 2, so it looks like argon. So it's going to have that. And then argon has 1, 2, 3. Alright, so all of them have 3 except for calcium. So it looks like by default calcium has to be the largest. And we have chlorine, Ca2 plus, and argon. So now we have to look at the number of protons. The more protons this has, if they have equal amount of shields, then it's going to be smaller. Calcium and argon have the same number of protons. Actually, no, they do not. They have same number of electrons. They do have different number of protons. Chlorine, different number of protons still. So the one that has the most protons is going to be calcium. So therefore, really, calcium is the smallest one. It's calcium 2 plus. We have the smallest one. And then we have argon, and then chlorine. So the more protons it has, the smaller it is. Argon has more protons, so it's smaller than chlorine. However, chlorine is smaller than calcium because calcium has more shielding. So that is the order of smallest to greatest atomic radius. And we have one more. Little corners in the way. So F and F minus. Looking at F has 1, 2 shielding, and F minus has 2 shields. Also, it just has the same number of electrons as neon does. So same number of shieldings. We've got to look at this the number of protons. Both of them are fluorine, so they both have the same number of protons. So what do? We got to go on to that third rule. It says if both shields and protons are equal, look at electrons. Given equal shielding and equal protons, more electrons means a bigger atom. Alright, so for this problem right here, shielding is equal, protons is equal. That means more electrons mean bigger atom. So fluorine is the smaller one. F minus is the bigger one simply because it has one more electron. And that is atomic radius looking at the periodic trends.